Hello everyone. Hey. Yes, I decided to put my lecture videos on YouTube because I hear some reports that Canvas was slow or not very responsive a couple of days. So I do not want it to happen anything. It's basically, in order to complete this semester successfully, we really have to rely on technology. And still, I think YouTube is the most reliable platform for that. Okay, so it's kind of all the way to do it: camcorder and internet access. Okay, that's what you are going to do. All right. For today, chapter 9 is estimating the value of a parameter. So what do we mean by that? Okay. So in chapter 8, what did we do? In chapter 8, we had a population where that was a proportion or the mean, okay, for qualitative random variable and the quantitative random variable. Depending on that, we had the proportion of a population and the mean of a population. From that, we did some distribution of these sampling, okay, sampling distribution. But as I said, it is kind of unnatural because how do you have those big data result and we talk about the smaller data? Of course, this accessibility for the big population, that is going to be always an issue, okay? So what we do, but what we did, okay, we did that chapter 8 part because it provides a theoretical background, okay? That's the purpose of it, and the chapter 9 is the real practical thing to do. Okay? So here we go. This time is the opposite. It's opposite. So we have a sample. We have a sample, and let's say we have a sample proportion, p hat. Okay. From this, we would like to generalize this result to the whole population over here. Of course, that is always a risky business. However, we have enough knowledge on statistics, so we can do so with some confidence and accuracy. Okay? Well, so this is the thing, the vocabulary. A point estimate is the value of a statistic. Yes, statistic is a numerical value that represents the sample. So for example, in this case, p hat. Okay, that estimates the value of a parameter. So in this case, this p hat is going to estimate p, okay, the proportion of a population. So, well, this p hat is going to estimate a parameter population, the proportion, and the x bar, the mean of the sample, will estimate this mu. And the mean of the standard deviation of a sample will estimate the standard deviation of a population. Okay, so that's the right way to go. So here, what is involved? Well, so the vocabulary, you got the concept, right? Okay, so this is known and this is unknown. We are going to estimate this population proportion using this sample proportion, okay? And of course, when you estimate it, you cannot pinpoint what would be this, this population proportion. So what do you have to do? We are going to just give some estimate, therefore you are going to give some interval range. So for example, it's a very simple thing. So let's say you took a test, okay? It's simpler than like a statistics test. So let's say you have some kind of multiple choice, okay, test. After the test, you do not know, exactly what your score will be. But based on for the number 1, yes or no, got it right or wrong, got it right or wrong. So but once you go through 20 questions, you can have a sample proportion, right? Okay. It's a proportion, and now you go for from there, you are going to, according to your estimate, it's like 80%. But it could go a little better, or it could go a little worse. So that makes like I can have a range for like from 75% to 85% like that. Okay, well, of course, like 70 to 95%. That is way too wide. Okay, so we are going to have a reasonable interval. Okay, so let's take care of this vocabulary. Example 9.11. The Gallup organization conducted a poll in which a simple random sample of 26 Americans 18 and older are asked, do you consider the amount of federal income tax you have to pay is fair? Well, that is a lot of proportion actually, okay? If I'm asked, well, I don't know what to say. So of these people, 1,000, I think 20, okay, let's say 20, I calculated on 16, okay? Of these people, Americans surveyed, 558 said yes. Okay, so the amount of federal income tax you have to pay is fair. Well, so 558 people said yes. Obtain a point estimate for the proportion of Americans 18 and older who believe the amount of federal income tax they pay is fair. Okay, this is relatively, think about it. This Americans 18 years or older, well, only just they picked what, 1,000, slightly over 1,000 people. It's pretty huge. Here is population. That means all Americans, okay, all Americans 18 years or older. Okay. So out of this, 558 people said the amount they pay for federal income tax is fair. So what is the point estimate? Well, that is very simple. Point estimate over here is who said yes among those people. Okay, so that is 558 over 1,016. So that gives you 0.549. That is p hat. So now the point estimate, yes, point estimate is 0.549 is going to estimate the population proportion p. Yeah. Yes, when you apply this one to the whole American population, 18 years or older, well, is it going to be valid? Well, are you going to regard it as valid? Well, we are going to study those things today. So this is the now. So naturally, let's start from here. When you apply this one to entire American population over here, huge population, of course this one is, let's say, 54.9%. That's what this sample says. When you apply this one to this, our approach is going to be, okay, this is going to be right in the middle. What we saw, well, it has to be true, but to generalize to American whole population over here, 18 years or older, you have to give a little upper, okay, go plus of this or minus of this. So we are going to say this is going to be confidence interval. Okay, so basically today what we are going to study is how do we make this construct this confidence interval. In order to do that, do we have a formula? I want to have a formula, right? Okay, so we have a formula for that. And can you do this by hand? Yes, we can do this by hand. Can you use a calculator to answer this, to find this interval directly? Well, luckily, yes, we do have a graphing calculator that can handle this confidence interval just as you just type in only 3 things over here. Okay? So watch this word, confidence. confidence is like a confidence in us that we can overcome coronavirus crisis like that. Well, it's kind of very particular meaning for confidence. All right. So here we go. There are two things about confidence. Okay. So confidence interval. For an unknown parameter consists of an interval of numbers, as I said earlier, okay? What you saw in the sample proportion, give a little buffer to above that or below that and make an interval. So the level of confidence, yes. So these are related, okay? Level of confidence, yes, you can change the levels, okay? So that is a kind of a little tricky one. So level of confidence is, okay, typically we use 90% or 95%, 90%, 95%, or 99%. These are the typical things that we do in the textbook and in real life. But when you do my math lab homework problems, because they randomize numbers, they may throw in like 89% or 93%, but just get ready for that, okay? So level of confidence, 90%, what they express is 100 times 1 minus alpha percent. So if that is 90%, so this portion is going to be what? 0.9, right? 0.9 times 100 is 90. So what does that mean? That means alpha equals 0.1. So have you seen alpha in this class? Okay. We saw a while ago, we saw this, z sub alpha. So for example, z sub 0.1 is what? This is a z value, the z value whose the area right to it is 0.1. This is a z value. So this is how we expressed it. Z sub 0.1 is a z value. The area region to the right is 0.1, like that. Okay. Well, but when you talk about in this confidence interval context, we are going to take half of it. Alpha, I'm going to show you why, okay? Alpha over 2 is what? 0.05. Okay? So alpha is this. So z sub alpha over 2 is going to be included. So that means z sub z of 0.05. Alright, so why do we split this one? Because this theory goes this way. We have a standard normal distribution curve over here, and therefore the median is 0, and the standard deviation is 1. And when you do this, yes, this is 0.1. We are going to split this 0.1 to the right end and the left end. You see? And we just, in other words, these are the kind of unusual cases. We do not want to look at those unusual cases, and then going inside is the most reasonable ones. So that's why we divide by 2 and this. So in this case, what is that? This is z sub 0.05. Okay? Z sub 0.05. Yes, we are going to use this one many times. So you can go to the table, or we can go to what? We can go to invert norm. But the invert norm gives you which area? And when here you are going to be asked to put the area first, but the area is going to be from the left end over here. So what is that? The area is 0.95 is the area. So here we go. We have to go to second bars, and the third option, invert norm, and the area is 0.95. and mu equals 0, sigma equals 1, and then go here, and then boom, that is 1.6448. So we are going to say 1.65. Oh, 1.645. Okay, so when you do that, 90% of a level of confidence, and then we are going to use it many times, so we need to have just this. So z sub 0.05 equals 1.645. This, we are going to use this number many times because this one is going to be a part of a formula, okay? So, likewise over here, the level of confidence is 95%, so that means this one has to be 0.95, is that right? Therefore, alpha is 0.05, therefore alpha over 2 is 0.025. Okay, so 0.025. So what are we looking at? So here is the right end, we give up this much, that is 0.025, and the left hand, we do not want this one, also 0.025. So when you put it on the, this is a z value, okay? How do you find this z value? We are going to use it many times. Well, again, invert norm. This time what? This area is going to be 0.975. Yeah, area, first thing, 0.975. So that gives you 0.9599. So this time, z sub 0.025 is 0.96. Okay, we can do that. And so you do the same thing over here. So this z is going to be 0.005, and the z value is 2.575. Okay, and we call these numbers, okay, these three numbers, yeah. Why did I do these three? Because 90%, 95%, 99% are the most popular level of confidence we are going to see. That's why. And this one will be part of a formula, and we call this critical numbers. Okay, so I want you to copy these three numbers. 1.645. That is critical numbers. Critical numbers. This is 90%. When you have 95%, yes, that is 0.96. When you have 99%, that one is going to be 2.575. Okay, critical numbers. Yes. So now, here we go. So what are we going to do over here is the general formula for confidence interval. Yes, the formula for confidence interval. That is a point estimate plus or minus critical value. We just talked about it, okay? So critical value. Critical number, critical value, okay? Critical value times standard deviation of the point estimate, standard deviation of point estimate. So you can use this formula for proportion or mean or standard deviation. You can use it, so that's why it's a general formula, okay? So more precisely, in this case, is going to be p hat. In our case, for today is estimating this popular proportion, okay? So p hat plus or minus critical value is what? Z sub alpha over 2. Remember that? Z sub alpha over 2 and the standard deviation of a point estimate. Well, that part is that you remember from last chapter, the sampling, when you have a sampling distribution of sample proportions. So what was the standard deviation? Square root of p times 1 minus p over n. But guess what? This time we are estimating p. This p is not available to us, okay? So what do you have to do? Yeah, we are going to use just p hat, okay? So it is going to be square root of p hat times 1 minus p hat over n. Of course, n, little n is a sample size, okay? So this portion separately critical value, and this portion is going to be standard deviation of a point estimate, okay? Okay, and yes, around this point estimate, we give a little buffer, plus or minus, and we call this whole thing over here, okay? We call this margin of error. So we are going to use capital E for that, okay? All right, so this is our formula. P hat plus minus Z sub alpha over 2. We already have those popular numbers written over there, and each time we are going to calculate that. It's not too bad, right? Okay? All right. So I can summarize. Confidence interval is p hat plus or minus, I'm going to say just this, margin of error, and then you understand what that is, okay? Alright, is a very, very important note. It must be the case that n times p hat times 1 minus p hat is greater than or equal to 10, and the little n is less than or equal to, in order to talk about this, in order to construct this interval. Why is that? So look, do you remember when it was required? Okay, in the previous section or chapter, in order to have the sampling distribution of sample proportion is normal, in order to talk about this normal distribution, we had this condition. Okay? In order to talk about normal distribution of a sampling proportion, yes, normal distribution, yes. In order to guarantee that, again, this is a normal distribution, that one is going to be, we are going to require that again. Why we change to p hat? Because p is unknown, okay? That is why we are doing this in the first place. So p is unknown, that's why we are, everything that we use the p, it will be switched to p hat.